So our next application of functions deals with sequences. So when you look here in our preliminary sequence equations activity, you'll see what we're talking about. So let's look at a sequence given by 7, 10, 13, 16. And it's going to be in this chart, and all I want to do is fill in the missing parts. So some of this looks self-explanatory. I see the term number for 4. It looks like if let's see, a sub 1 equals 7, a sub 2 equals 10, a sub 3 equals 13. Notice I'm saying a sub whatever because it's a subscript, so keep that in mind. So a sub 4 is going to be 16. Now let's fill in the rest. So term 5 is called a sub 5, which is 19. Term 6 is a sub 6, which is 22. And you know how I'm getting this number, right? You notice I'm continuously adding 3. So a sub 7. Term 8 is a sub 8. Term 9 is a sub 9. And term 10 is a sub 10. 34. Yes. What is the domain of this sequence? This is why we're talking about this in terms of functions. So the domain is going to be my input value. And usually in a table, my input value is the first. That's what we've sort of done for all of our other function practices. So let's just continue the same thing here. So my domain is 1, 2, 3, and so on. Again, braces, ellipses, increasing order. My range appears to be 7, 10, 13, and so on. What does the subscript on a sub n represent? Well, it represents the term number. It actually represents the term number, my bad. The position, it names the position. First term, fifth term, 10th term, whatever it may be. What does a sub 12 represent? I love to use this word. It represents the 12th term. And what is it? Well, check this out. We'll just continue this table. A sub 11 is 37. And so a sub 12 is 40. How would you get from one term to the next? Well, what have we been doing all this time? We've been adding 3. Nice. Now, they're telling me the equation for this sequence is 7 plus 3 times n minus 1, and I need a sub 33. So a sub 33 is 7 plus 3 times 33 minus 1. So 7 plus 3 times 32, 96 plus 7, 3. All right, it's 103. So that's sort of everything I need to know. I do want to point out one thing to you, however, that is whenever you look at this equation, I want you to notice here, let's look at, notice the first term is 7, and notice that shows up here. Notice that we added 3 to both sides, and that shows up here. That's going to help us down the road. All right, so let's practice a few of these. So it looks like the first thing we want to talk about is the recursive form. That's the first subsection here. Now, when something recurs, that means it goes on, it happens constantly. So let's see what happens here. Use each of the following equations to generate the first 4 terms of each sequence. Write them using the notation. Okay. So they tell me a sub 1 is 6. My first term is 6. So I'm going to use my term numbers here to help me out. So I know that a sub 1 will be a sub 1, oh, just kidding. A sub 2 is what I need next. That's a sub 2 minus 1 plus 7. That means that a sub 2 is a sub 1 plus 7. What's a sub 1 in this problem? 6, and 6 plus 7 is 13. A sub 3 is a sub 3 minus 1 plus 7. That's a sub 2 plus 7. What's a sub 2 in this problem? 13. And we get 13 plus 7 is 20. A sub 4 is a sub 4 minus 1 plus 7. 4 minus 1 is 3. So a sub 3 is 20 plus 7. We get 27. So to me, my first term is 6. My second term is 13. My third term is 20. My fourth term is 27. What's happening to each of these? I'm adding 7 each time. So keep that in mind as we go through. Okay. Number 2, a sub 1 is 10. A sub n equals a sub n minus 1 minus 4. All right. So to get the second term, we do 2 minus 1. Well, 2 minus 1 is 1. And I know a sub 1 is 10. So 10 minus 4 is 6. A sub 3 is a sub 3 minus 1 minus 4. Well, 3 minus 1 is 2. A sub 2 is 6. 6 minus 4 is 2. Okay. A sub 4 is a sub 4 minus 1 minus 4. That's a sub 3 minus 4. A sub 3 is 2, and 2 minus 4 is negative 2. Does it kill me that I don't have room down here? It does, but I'll survive. So a sub 1 is 10. A sub 2 is 6. A sub 3 is 2. Dang it. And a sub 4 is negative 2. Oh, there it is. These equations are given in recursive form. Explain what this means. Well, this means that you can find the next term by adding to the previous term or subtracting to the previous term. Okay. Identify the common difference. The common difference is, what did I add? Okay, to get to the next term. At the table above, we added 3, so the common difference was 3. So what did I add in example number 1? It looks like I added 7. So D equals 7. And in number 2, what did I add? Well, I subtracted 4, which means I really added negative 4. And here's the connection I want you to make here. You see how the common difference is 7? Look where it shows up in the equation. And this common difference is negative 4. It shows up here in the equation. All right, so keep that in mind, or in the formula, I should say. Now, so the recursive formula works great whenever you need to find the next term. To find the second term, add to the first term. To find the 10th term, add to the 9th term. And that's great for when we have a whole string of numbers. But suppose I asked you for the 1000th term. Well, to find the 1000th term, you need term 999. But in order to find term 999, you need 998. But you need 997, and so on. So sometimes recursive isn't the best. Recursive is great where I'm having you continue a pattern. However, whenever we are using the explicit form, that will tell us any term right away. If I need the 1000th term, well, 1000, remember, refers to the position. So I would let n equal 1000 here. And you'll see as we go. So I'm kind of getting a little ahead of myself because this stuff is super exciting. But anyway, let's continue. Use each of the following equations to generate the first four terms of each sequence. Write them using the notation. Assume the domain is 1, 2, and 3. So that means let's look at term 1. So we're going to substitute 1. 0 times 7 is 0 plus 6 is 6. So 6 plus 7 stays the same. N is 2 now to find the second term. 1 times 7, 7 plus 6. So to find the third term, we substitute N equals 3. 2 times 7 is 14 plus 6 is 20. To find the fourth term, we let N equal 4. 3 times 7 is 21 plus 6 is 27. So my first term is 6. My second term is 13. My third term is 20. My fourth term is 27. And I don't know if y'all noticed this, but 6, 13, 20, 27, 6, 13, 20, 27, they're the same thing. Sometimes you need to see that because it's kind of fun. All right, let's look at number 6. I have a sub n equals 10 minus 4 times n minus 1. So a sub 1 is 10 minus 4 times 1 minus 1. 0 times 10 minus 0 is 10. A sub 2 is 10 minus 4 times 2 minus 1. 10 minus 4 is 6. A sub 3 is 4 times 3 minus 1. 10 minus 8 is 2. A sub 4, we let n equal 4. 10 minus 12 is negative 2. So again, I have the same sequence that I did previously, but previously you saw the recursive form, and now you are seeing the explicit form. So recursive says I can always find the next one. Explicit says I can find any one. So these expressions are given in explicit form. What does this mean? I can find any term. So recursive gives you the next term, explicit gives you any term. And identify the common difference. Well, for number 1, the difference was 7 because we added 7 to get the next term. For number, oh, this is my bad. This is for number 5. For number 6, we subtracted 4, so the common difference is negative 4. And again, this doesn't help unless you can make the connections. So look here. My common difference is 7. Look where it shows up in the explicit formula. My common difference is negative 4. Look where it shows up in the explicit formula. So keep that in mind. So this is normally the activity we do, and we have people figure stuff out. And then we sort of cement everything with our formal notes, because you know me, I've got to have the notes. So what we've been using are arithmetic sequences. An arithmetic sequence is a sequence in which the difference between two consecutive terms, remember consecutive is one after the other, the difference is constant. Let's actually make that note. The difference is constant. That means we're adding the same number each time. There are no changes. There are occasions where sometimes you want to add different numbers, but then it's not arithmetic. So we want to add the same number each time to get the next term. And we've already talked about the common difference, which is D. Oh, we also talked about the next thing. When you add to get the next term, the common difference is positive. When you subtract to get the next term, the common difference is negative. So we are going to talk about recursive and explicit. So let's go through some notation, because this is what you're going to see on the formula sheet for the unit test and for the end of course test. So remember we talked about the subscript of 1. A sub 1 is really term 1, but we use the ordinal first. A sub n is term n. Now, when you see a sub n minus 1, I briefly did math in the subscripts for like a second, but I want you to think of this as one whole variable, one package together, and that means the previous term. Because if I'm talking about a sub 5, you're going to mess with a sub 4. If I talk about a sub 17, you're going to want to do something with a sub 16. That's all it means. And then D is our common difference. And now over here, when we talk about the explicit formula, a sub n, remember, this is term n. A sub 1 is term 1. So please notice for both of these, whether it's a recursive formula or an explicit formula, you need the first term and you need a common difference every time. Notice that shows up in both of them. I mean, it shows up in the definitions, but look in the body of the equation. You need both of those parts. So let's practice a few of these. And boy, I'm looking at example 1 here, and I'm sort of regretting it because it's basically a rehash of my activity. But let's say this is for people who've seen it for the first time. So we've got 4, 7, 10, 13. What are the next terms? Well, add 3, right? Isn't that what we did? Plus 3, plus 3, plus 3, plus 3. I'm sensing some slope here, but I'm just going to keep that in the back of my mind. You know, anyway, what's the common difference? 3, because we had to add 3. What is the recursive formula? Okay, so the recursive formula up here, it tells us, give me the first term. My first term is 4. Now I need directions on how to get the second term. So I keep a sub n, and then I keep a sub, so the current term is the previous term plus d, which in this case is 3. The explicit formula, a sub n equals a sub 1 plus d, which is 3 times n minus 1. So those are the main formulas, but I've also seen it sometimes written as a sequence. And the way they want you to write, or as a function, my bad. So to write the function, you rewrite the explicit formula in simplest form. So let's do that. So, oh, I'm so glad I'm looking at that because I did this wrong. What's a sub 1 in this problem? Dude, I'm tripping. 4. So we have 4 plus 3 times n minus 1. So let's look at that as a function. I have to write the problem. It's a habit. And now I need to bring down the 4, distribute the 3. My like terms, I have 3n, and then 4 minus 3 is 1. Okay, so here's my function. And you all remember earlier I talked about slope? Well, there's your slope. There's a y-intercept. Just throwing that out there. All right. I want to write the first 3 terms for the following. So what I'm doing here, excuse me, is I'm giving you all the information you need, and you're going to give me the first 3 terms. And we can do this any way you'd like. I'm not going to skip any steps since we're starting with this. So a sub 1 is 4. A sub 2 is a sub 1 minus 5. So that's 4 minus 5, which is negative 1. A sub 3 is a sub 2 minus 5. So negative 5 minus 1 is negative 6. So it looks like I've got 4, negative 1, negative 6. And it looks like I'm subtracting 5 as I go. Yup, that's right. Okay, for this one, to find a sub 1, we let n equal 1. Oh, it's on that side. That's okay. 3 times 0 plus 7. To find the second term, we let n equal 2. 3 times 1, 10. Oh my gosh, Ruby, you're so boring. It's the same problem showing up over and over. So now for the third term, n equals 3. 3 times 3. No, 2. 3 times 2 is 6. Oh my gosh, that's showing up everywhere. All right, so there's my first three terms. Oh, and now I have a function. So to f of 1, well, excuse me, will be my first term. Let n equal 1. So we get negative 2 plus 6, which is 4. F of 2 will let n equal 2. Negative 4 plus 6 is 2. F of 3 is where n equals 3. We get 0. So my numbers are 4, 2, and 0. Okay. Now, sometimes you're going to have a list, like in example 1. Sometimes you'll have formulas. Sometimes you'll have pictures. And I don't draw pictures. I just use O's. I just did a series of O's. So let's look at figure 1. Figure 1 has 6 circles with 5 below it. Figure 2 has 5 with 4. Figure 3 has 4 with 3. All right, draw the next two figures. So it looks like the next one will have this, and then the next one will have this. It looks like we're decreasing a circle each time. So in number 1, so fill in the table. Figure 1, figure 2, figure 3. So in figure 1, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Figure 3, 1, 2, 3, 4, 5, 6, 7. And I bet we have figure 5 O's and then 3 O's. 5, yeah, there it is. Okay. What is the common difference here? So now I'm just going to focus on the table, if you don't mind. Common difference is negative 2 because we're subtracting 2 as we go. Okay, the explicit formula. We need our first term, which is 11, minus 2 times n minus 1. Okay, Robideer, it says plus d. Yes, it does. But in this problem, d is negative 2, so we're going to substitute the whole negative 2 in there. Because remember, when you add negative 2, you're subtracting. So likewise, the recursive formula requires the first term. And in this problem, the first term is 11. And the nth term, we also need a common difference. So it's our previous term minus 2. And then the last one, I had to put a word problem in there just to keep me honest. So we've looked at functions as a list of numbers, as a formula, as a figure, and now as a verbal expression or a verbal description. Rusty ran 2 miles on Monday, and he wants to increase his distance by 1/2 mile each day. Create a sequence that represents the distances he will run for Monday through Friday. Okay, so for Monday, he will run 2 miles. What happens on Tuesday? He increases by 1/2 mile. On Wednesday, 2.5 plus 1/2 is 3. Add 1/2, add 1/2. Is that Monday, Tuesday, Wednesday, Thursday, Friday? There's everything. So just remember, an arithmetic sequence is a list of numbers where you add to get the next term. Always know the common difference, how I get from one term to the next. Always know my first term, and then you should be all right.